There's a house in New Mexico right now sitting under direct sunlight in the middle of July, and the temperature inside is 20 degrees cooler than the air outside. No air conditioner, no fan, no electricity moving through the walls. Just dirt, packed ordinary earth. And the total cost to build the system that makes it work was less than $50. Not 50,000, 50. When I first heard that number, I assumed it was exaggerated, simplified for effect, the kind of claim that falls apart the moment you look closely. But then I stepped inside one of these homes just outside Taos, and the air did not feel like summer air anymore. It felt stable, cool in a way that did not come from a machine. Not cold air being pushed at you, but the absence of heat itself. The kind of cool you feel when you walk into a cave or step into an underground cellar. The kind that settles on your skin gently instead of blasting at it. And that is when I realized something that should have been obvious. The most powerful cooling system ever used by humans is not something we invented in a laboratory. It is not something patented or sold or installed by certified technicians. It is something we stand on every single day. Something we build our foundations on and bury our pipes through and never once think of as a tool, the earth itself. For thousands of years, before electricity, before compressors, before refrigerants and thermostats and the monthly bills that come with them, entire civilizations understood a simple principle that modern construction has almost completely forgotten, deliberately or otherwise. The deeper you go into the earth, the more stable the temperature becomes. At just 6 to 10 feet below the surface, the ground temperature remains nearly constant year-round, typically between 50 and 60 degrees Fahrenheit, depending on your location and latitude. It does not matter if it is the middle of winter and the air above is below freezing. It does not matter if it is peak summer and the surface temperature is pushing over 100 degrees. A few feet down, the ground does not care. It holds its temperature with a consistency that no mechanical system can match. It does not fluctuate. It does not overheat. It does not break down in the middle of August when you need it most. The earth simply holds. And if you can bring air into contact with that stable underground environment before it enters your home, you can cool that air without using a single watt of electricity, without a single moving part, without a single maintenance call. This is not theory. This is not experimental. This is not a fringe concept circulating in homesteading forums. This is a system that has been used for centuries across multiple continents, documented in ancient texts, preserved in surviving architecture, and quietly working inside buildings that predate the United States by thousands of years. In ancient Persia, underground air channels called qanats were used not just for water transport but for active temperature control, pulling hot desert air through long subterranean tunnels where it shed its heat into the cooler surrounding earth before entering homes and palaces. In North Africa, similar principles were integrated into courtyard architecture, where air was drawn downward into shaded earth-cooled chambers and then circulated upward into living spaces through careful use of natural convection. In the windcatcher towers of Iran and the Gulf region, architects designed entire buildings around the movement of air through thermally stable underground chambers, creating passive cooling systems so effective that interior temperatures remained comfortable even during desert summers without a single mechanical component. Even in parts of Europe, root cellars were not just for food storage, they were proof of something fundamental. Proof that the earth itself could maintain temperatures far below the surrounding air indefinitely, without any assistance, without any fuel, and without any cost beyond the initial labor of digging. And yet, despite thousands of years of evidence accumulated across dozens of cultures on multiple continents, almost no modern home uses this principle. Not because it stopped working, the physics has not changed, not because something better replaced it. There's no technology available today that can cool air for free with zero maintenance and infinite lifespan, but because it does not require ongoing consumption. There is no monthly bill attached to air that cools itself underground. There is no component that wears out and needs replacing every 10 years. There is no industry built around servicing something that does not break. There is no recurring revenue model for a trench filled with pipe. And in a construction industry where homes are increasingly designed around what can be sold to the homeowner after move-in, that is a fatal flaw. Not for the homeowner, for the seller. And so it quietly disappeared from standard practice, not through obsolescence, but through irrelevance to a business model that depends on dependence. The system itself is almost absurdly simple, and that simplicity is part of what makes it so easy to dismiss at first. A pipe, usually PVC or corrugated drainage tubing of the kind available at any hardware store, is buried 6 to 10 feet underground, running horizontally from outside the house toward an interior vent, often through a basement wall or crawl space. As hot air from outside enters the pipe, it travels slowly through the cooler earth surrounding it. Heat transfers from the air into the ground through the walls of the pipe. By the time that air reaches the interior end, it has dropped significantly in temperature, in some cases by 15 to 20 degrees Fahrenheit, sometimes more in optimal conditions. The longer the pipe, the more surface area in contact with the earth, and the greater the cooling effect. The deeper the burial, the more stable and reliable the temperature of the surrounding soil. and the more consistent the performance across seasons. This is called an earth tube system, and it goes by several names depending on where you encounter it. Ground-coupled air systems, earth-air heat exchangers, Hipparcos-inspired cooling, underground ventilation channels. The terminology changes, but the physics is identical everywhere. A single 100-foot length of buried pipe can transform the temperature of incoming air in a way that would cost thousands of dollars to replicate with mechanical equipment. No compressor, no refrigerant cycling through chemical phase changes, no loud outdoor unit sitting next to your house humming through the night, no moving parts of any kind except the air itself, which moves through the system either passively through natural pressure differences or with the gentle assistance of a small low-wattage fan if additional airflow is needed. In some designs, even that fan is unnecessary. Natural convection, the simple tendency of warm air to rise and cool air to settle, creates a slow, continuous movement through the system without any mechanical encouragement at all. Now compare that to what most homes in America were built to rely on. A standard central air conditioning unit costs between $5,000 and $15,000 to install, depending on the size of the home and the complexity of the ductwork. Once installed, it consumes thousands of kilowatt hours of electricity every year, a number that increases as the system ages and efficiency drops. It requires annual maintenance visits, refrigerant recharging, filter replacements, coil cleanings, capacitor checks. Every 10 to 15 years, the unit itself must be replaced entirely because the cost of repair approaches the cost of replacement. Over a 20-year period, the total expenditure on cooling a single home using conventional central air, when you account for installation, electricity maintenance, and one full system replacement, can easily exceed $20,000, often significantly more in warmer climates where the system runs for 6 to 8 months of the year. An earth tube system, once installed, costs nothing to operate. Nothing. Not reduced to a minimal cost. Not offset by some other expense. Literally nothing. The ground does the work. The physics does the work. The differential in temperature between the surface air and the buried earth does the work. The system simply creates the conditions that allow it to happen and then gets out of the way. There is no ongoing cost because there is no ongoing mechanism requiring energy. There is no wear because there are no moving parts to wear. There is no failure mode except for blockage or condensation mismanagement, both of which are addressed in initial design and require no ongoing attention once resolved. And here is where the picture becomes larger than a single homeowner's utility bill. Because if systems like this were incorporated into residential construction as standard practice rather than as fringe alternatives, the cumulative impact on energy infrastructure would be staggering. Cooling accounts for a significant portion of residential electricity consumption in warm climates. During peak summer days, air conditioning load is one of the primary drivers of grid strain. The reason utilities implement rolling demand charges, the reason power plants that would otherwise sit idle are brought online specifically to meet afternoon cooling demand. If even a fraction of that load were reduced through passive systems, the downstream effects on grid infrastructure, on peak generation requirements, on transmission losses, on carbon output from fossil fuel peaker plants would be substantial. Entire regions could reduce their dependence on electrical grids during the most strained periods of the year. Utility companies would sell less power. HVAC manufacturers would sell fewer units. The demand for refrigerant, for copper coil, for sheet metal ductwork, for programmable thermostats and smart home HVAC integrations would shrink accordingly, which is perhaps why, when you look at the trajectory of residential construction over the past century, you find that the movement has been consistently in the opposite direction. Homes built tighter, more sealed, better insulated against the outside environment, which sounds logical on the surface, but which has the secondary effect of making passive exchange with that environment essentially impossible. A home that is sealed against outside air is a home that must generate its own interior climate entirely through mechanical means. It cannot borrow coolness from the ground. It cannot use the temperature differential between underground and surface as a resource. It must burn energy to create and maintain every degree of comfort, from the first day of occupation to the last. And that ongoing energy burn, multiplied across millions of homes and decades of occupancy, becomes the foundation of an industry whose continued existence depends on the problem never being solved. But the scale of that systemic problem does not need to stop an individual homeowner from solving it for themselves, because unlike architectural changes that would require redesigning the construction industry from the ground up, this is something you can actually implement in a weekend with tools available at any hardware store and materials that cost less than a new thermostat. A basic earth tube system requires a trench, a length of pipe, a weekend of labor, and a willingness to dig. The trench should be 6 to 8 feet deep enough to reach the zone of stable soil temperature, and it should run from an exterior intake point away from the building toward a basement wall or crawl space entry point. The pipe, either 4-inch or 6-inch diameter depending on the desired airflow volume, should be laid with a slight slope toward the exterior or toward a low drainage point. so that any condensation that forms inside the pipe can drain out naturally, rather than pooling and creating moisture problems. The pipe should be sealed at all joints to prevent soil gas infiltration. The exterior intake end should be fitted with a screen to exclude insects and debris, positioned away from sources of polluted air, and ideally shaded to prevent preheating the incoming air before it even enters the system. The interior end should connect to a simple vent that can be opened or closed depending on whether cooling is desired. That is the complete system. Hot air enters from outside. It travels through 100 feet or more of pipe buried in 55-degree earth. Heat moves from the air into the soil through the pipe walls. Cooled air emerges inside. There are no switches to flip, no settings to program, no filters to change on a schedule. The system runs whenever air moves through it and does nothing when it does not need to. In a passive design without a fan, airflow is driven by the same natural convection that drives wind, the movement of air from higher pressure to lower pressure, from warmer zones to cooler ones. In a semi-passive design with a small fan, a 20-watt DC fan can move enough air through the system to meaningfully influence the temperature of a significant portion of a home's interior, at a fraction of the energy cost of even the most efficient conventional air conditioner. Now, because the earth tube system works through direct temperature exchange between moving air and stable soil, it has specific conditions under which it performs best and specific limitations that must be understood before installation. In dry climates, the performance is exceptional. The air entering the pipe is low in humidity. The temperature differential between surface air and buried earth is large, and the risk of condensation inside the pipe is minimal. In these conditions, the system functions almost exactly as described, delivering reliably cooled air with no complications. In moderate climates with seasonal humidity, the system still performs well, but condensation management becomes more important, and the pipe slope and drainage design must be carefully executed. In very humid climates, hot and wet simultaneously, the situation becomes more complicated. When air is already saturated with moisture, cooling it further as it passes through the pipe can cause significant condensation. And if that moisture is not properly drained, it can create conditions for mold growth inside the pipe, which would make the system counterproductive. In these climates, earth tube systems require either more careful engineering, additional dehumidification at the intake, or may simply be less appropriate than in drier regions. In areas with high groundwater tables, the depth of burial must be carefully assessed to ensure the trench does not intersect with saturated soil, which would affect both the soil temperature profile and the structural integrity of the installation. In regions with expansive clay soils, freeze-thaw cycles at the pipe depth must be considered. None of these challenges are insurmountable, and none of them undermine the fundamental physics of the system. But they do require that any installation be planned with an understanding of local conditions rather than as a purely generic recipe applied identically everywhere. What makes the earth tube concept so persistently remarkable across all of these practical considerations and limitations is not just that it works where conditions are right, it is that it has always worked. For the entire span of human civilization, in every era and on every continent where people have tried it, the ground beneath their feet has been offering the same quiet service. Summer heat waves pass over it, winter freezes grip the surface above it, decades become centuries, become millennia, and a few feet below the surface, the temperature holds. It holds because the Earth's thermal mass is so enormous, so deep, so vast in comparison to the seasonal fluctuations of surface weather, that those fluctuations simply cannot penetrate far enough to disturb it. The sun beats down on soil all summer and manages to warm only the top few feet before the thermal wave runs out of energy. The deepest cold of winter barely reaches further. Below that zone of seasonal influence, the ground settles into a temperature that reflects the average annual surface temperature of the region, and there it stays, steady and available, year after year, century after century, requiring nothing from anyone. Modern homes ignore it completely, not because engineers do not know it is there, not because the physics is somehow unavailable in architectural textbooks, but because a system that requires nothing cannot be sold repeatedly. A system that lasts for the lifetime of the building without a single service call does not generate the kind of ongoing economic relationship that the construction and HVAC industries are built on. A solution that costs $50 once and then works indefinitely does not fit into a business model organized around products that need to be replaced, systems that need to be maintained, and homeowners who need to be dependent on someone else's expertise to stay comfortable in their own homes. But the ground is still there. The temperature differential between surface summer air and buried stable soil is still there, just as it was when Persian engineers were routing air through underground tunnels, just as it was when North African architects were designing courtyards around it, just as it was when every civilization that lived without electricity found ways to let the earth do the work that we now pay thousands of dollars annually to do mechanically. The physics has not changed. The opportunity has not closed. The trench can still be dug. The pipe can still be laid. The system can still be built over a weekend by a person with a shovel and the patience to understand what they are actually working with. And once you build it, once you feel that air moving through your vent on a July afternoon, air that entered your system at 95 degrees and arrives at 70 or below without burning a single watt, something shifts in how you think about the relationship between buildings and the environment they sit inside. Because you realize that for most of human history, that relationship was not adversarial. Homes were not sealed boxes fighting the outside world. They were designed to work with it, to use what the environment offered, to take coolness from the ground and shade from overhangs and breeze from carefully positioned openings, and thermal mass from stone and earth walls that absorbed heat during the day and released it at night. The modern sealed home, dependent on mechanical systems for every degree of comfort, is not an improvement on that relationship. It is a severance of it. And the cost of that severance is paid every month, every summer, every decade, in electricity bills and maintenance contracts and eventual replacement costs that accumulate quietly into the tens of thousands over the life of a building. The next time you feel that blast of mechanical cold air from an air conditioning vent, take a moment to notice what it actually is. It is electricity converted to heat removal. It is refrigerant compressed and expanded through a chemical cycle. It is a machine doing something, loudly, expensively, continuously, that the earth beneath your home would do for free. And a few feet below your foundation, that offer still stands, quietly, patiently, exactly as it has for millions of years, waiting for someone to dig a trench and take it.